Good afternoon, guys.
Yes, sir.
Take a look at noise in a different kind of modulation. Well, we're gonna start with FM modulation. So I think we'll use this class to take a look at noise in FM. Okay, we have 4 people. Let me give them another few minutes. Okay, I'll be right back. Okay, relative. Still only have 4 people. What is going on? We have a lot to get through today. And once we start, but that makes sense them coming, because they're not gonna be able to follow. Oh boy. Okay, guys, we have 6 people. Let me start. All right. So like I said, today we're gonna start looking at noise in modulated signal. So we'll start with the FM signal. So we're gonna look at noise in the FM signal today. All right. So first we want to recap. I have a nice PowerPoint for you here today. FM, and we look at system modeling noise, derivation of the signal, the output signal to noise ratio, the pre and the emphasis. Look at a little comparison with AM. All right. Recapping frequency modulation. Fundamental difference between AM, amplitude modulation, and frequency modulation. So by definition, amplitude modulation message, amplitude modulation. The message information is contained in the signal amplitude. Right? So I want to say obvious. Because any signal you're gonna have some noise in it. Right? So this noise corrupts directly the modulated signal. So it's the noise is in the amplitude. And that, because that's what we're gonna, the means of modulation, the amplitude. So you corrupt the modulated signal. So you corrupt the amplitude. On the other hand now, frequency, the message information is contained in the signal frequency. The effect of noise on the FM signal is determined by the extent to which okay. Remember, in FM signal, our carrier waveform where theta I of t is the instantaneous phase angle, and this is revision. S of t now. So the instantaneous, the I here, so the suffix I is instantaneous. So we just gonna get an instantaneous frequency by using that instantaneous state. So in FM, the instantaneous frequency of the carrier varies linearly with the message. Let's see if we can figure that out from above here. This is your frequency. Call this. All right. So y equal mx plus c, in this case c0. But we are going to put a generalized fc. All right. So y equal mx plus c. So we're going to define kf as the frequency sensitivity of the modulator. All right. So assuming theta I equals 0, theta I of t is given by this integral. Straightforward so far? Okay. Your modulated signal, which is given by this, which is a convolution of your message signal and your carrier signal, is given by this. Oops. Okay. Mr. Golab, are you following? Mr. Golab, are you here? Okay, doesn't look like Mr. Golab is with us, so Mr. Steele.
Yeah, I'm here, sir.
Are you following what we're doing here?
Yeah, I'm trying to.
Good. All right. Let's carry on. Bandwidth. Of FM. So we define MP as the maximum M of T, which is the peak message amplitude. So FC minus KFPMP is less than the instantaneous frequency, which is FC minus KFMP. So here, FC is a carrier frequency. What is KFMP?
What is it, sir? KFMP.
Mm-hmm.
Oh, the frequency deviation.
Yeah, it is. Go back a little further. You say you just follow this, you know. All we change is MT from there. And call it MP there. And we define MP as that value in that equation above that would designate the peak message amplitude. So FC minus KFMP less than the instant, which is does that need any explanation, by the way? Or is straightforward?
Try to explain is the straightforward.
Huh? This
Try to
is
explain it. Try to explain it.
yeah, so you understand it now. This is the minimum. This is the maximum.
Yes, sir.
Yeah? Okay. So the frequency deviation then, right? This is equal to the deviation of the instantaneous frequency. All right. frequency deviation. It is the deviation of the instantaneous frequency from the carrier frequency. Right? So if you do the subtraction up there, you get delta F, which is equal to this. And we're going to define now the message bandwidth as W. So the deviation ratio is the frequency deviation. That is frequency deviation delta F is equal to this. Instantaneous frequency from the carrier frequency. Carrier frequency minus instantaneous frequency give you this. Right? And this over the message bandwidth, W, equal the deviation ratio, which is beta. For a small beta, FM bandwidth is approximately 2 times message bandwidth. For a large beta, FM bandwidth is much, much greater than this. This is the wide minus the bandwidth, the FM. Although given in a material, I don't read it. I don't know about Carson's rule, but the Carson rule after BT equal to beta plus 1. So let us go to where we really want to go now. So let us model the FM receiver. So here you have your FM signal. And you have your noise. So that is the noise acting as here in our picture. What the noise behave like? Anybody?
Sir, the message, sir.
No, man, it behave like the carrier. The FM signal is the message. Hear me?
Yes, sir.
So the noise now is behaving like the carrier. Because remember when we looked at it earlier, we would have the message signal and the carrier signal. So we have the convolution here. Right? And we send that to a bandpass filter. We meet on the affirmation. You hear me there?
Sir, it is not. I'm pressing it, but I'm not getting any response.
Yeah. Huh?
So I'm going to rejoin the class. Answer.
Huh? You have it now? You have permission there.
Not we're recording, sir.
The band pass filter removes any signal outside the bandwidth of the carrier frequency. So the bandwidth of the carrier frequency is FC minus BT over 2 to FC plus BT over 2. All right? So BT is the bandwidth. So the pre-detection noise of the receiver is band pass with a bandwidth of BT. FM signal has a constant envelope. You use a limiter to remove any amplitude variation. And the discriminator is a device with output proportional to the deviation in the instantaneous frequency. So it recovers the message signal. And the band pass, on the low pass has a bandwidth of W. It passes the message signal and removes out of band noise. So we have defined the band pass, the limiter, the discriminate, and the low pass. Some facts. FM is nonlinear modulation, meaning the superposition doesn't hold. Nonetheless, it can be shown that for a high signal to noise ratio, noise output and message signal are approximately independent of each other. So the output is approximately the message plus the noise. Any nonlinear system are locally linear. Noise does not affect power of the message signal at the output. Meaning we can compute the signal power for the case without the noise and accept that the result hold for the case with the noise. So let us look at the power of the signal at the output without the noise. From above, the instantaneous frequency of the input signal is given by Fi equal Fc plus Kf mt. All right. Goes through the discriminator, it drops the Fc. So output signal power is given by Kf squared times P, where P, the average power of the message signal. So what happens when you add the noise to it now? This part is your noise. When you do the math, you get this XT. Tell me if you follow that math. But this is your cat. This is your carrier. This is your noise using Pythagoras. This is the resultant. So this is the formula from that phasor diagram for your instantaneous angle.
Hello, sir.
Yeah.
Oh, okay, sir. I was having some trouble earlier, sir. Talking and so, but I was asking if we made a final decision on the lab, or we would submit what we did, or we wouldn't bother with it at all.
Just send me what you guys have.
Okay, okay.
Because I tell them that I ask folks to like contact me outside of the class and we go through it kind of together. But nobody not really remember to do that. So just send me what you have.
Okay.
So to increase signal to noise ratio and FM to cut off high frequency at the output. So if you get so suppose I give you one of those modulator system circuit and ask you to tell me what each of the component will do. You know what the low pass filter will do. You know what the band pass will do, the limit and the discriminate and so on. So here are the clarification of the preemphasis and the de-emphasis. They are both filter. So tell me now, what do I mean by preemphasis and de-emphasis? All right, so with the preemphasis, I use a filter. All right, to filter out the noise as much as possible before I put it through the modulator. Mhm. And when I go to the receiver now, use a de-emphasis again to get out whatever other noise you have there. You with me?
Yes,
So,
sir.
so in other words, and I'm gonna put this now. See, all right.
So you say it filter out the pre-emphasis filters the noise and the de-emphasis adds it back at the end.
Yeah, man.
Okay.
They're both getting rid of noise, but this is at the input before you go through your convolution or your modulation. Right? You take out the noise. Right? And then, I mean, of course, not everything. Go through that. And then at the end now, before you convert it back to the message, you try to do some more filtering. So suppose now, all right. Whatever you will do with Digicel or what the other one named Flow, that's just line technician job. If you get a job at one of these companies that make modulator, develop modulator, you might spend your 30, 40-year career just working on a little part of the FM receiver. Right? Or a little part of the de-emphasis filter. You never get a whole, you would never design a whole filter because the way this works, you know. All right. When I was at Intel, I was working on but if me tell you know which generation of the microprocessor, when I realize it,
Intel Pentium.
Eh? Say
Intel
what?
Pentium 4.
I will tell you.
You're famous, sir. You're famous.
So it was a very old somebody there. And you know I was just working on one transistor in the entire chip. Guys have hundreds in engineering. And on that transistor, I would even say the whole transistor. But so I said that to say this. What you would get from a course like a general, you go to advanced study now, you might get into like a project might be to design before I reach that. Like say you're working on the emphasis team, right? Over the years, everybody will start from scratch now. Because over the years, this thing developed. So you have chunks what you call library. Right? So if you have put together a filter like this, you have blocks to put together to move you from here to here. Right? But then you might your job or your team's job now might be to make this smaller or faster, you know, or in efficiency or whatever. So you might have to go into one of these blocks and focus on it and spend years on it. You know. Like, when I was at TI, you know, I work on, we chip my work on at TI. Since you know so much about revision. Nobody now will tell me. I said, which ship my work on there, the last one.
Never they read so far.
Okay. You remember that one Nokia? It was a little bit up from the banger. You call it our 8086. It was just start coming into smartphone.
Talk, sir.
ARM processor you're talking about there? The ARM architecture?
No, yeah.
Okay.
Actually, may have an invention from that chip.
You got the patented?
I think we can find that pattern. Yeah, that's a Victor Wattens. I think we can find that in some company, you know, and every time them see somebody I come at them, I not tell them, no, son, if we do this, you know. But every time all them guys in England see somebody I come to Jamaica, they send me clocks and a whiskey and thing. I feel good, man. I say, why, sir? we really appreciate, you know, so you knock we over our head for at least learn the thing and the grade will come. I'm not a hard person when it comes to grade. I just want to know, say, I just no copy and get grade, learn something. All right? So the rest of this is just a kind of wrap up. Okay. All right. You see it? See what I mean? This is just a simple preemphasis circuit. It is a filter, yeah? So your job might be to work on a capacitor or the resistor. Right? You know what I always struggle with, and this is the emphasis. I always struggle with the whole concept of you know, when you start engineering school, you really don't understand what it's all about or what you're doing now. You know, because, you know, when I left Fifth Farm and go to CAS, I'm going to tell my mother, so I'm going to do engineering. She think I'm a mechanic, I'm going to do. So we are town, go in an engine farm. And then the green had one shop just down the road. So. Then the green was a little village mechanic, you know? So, but anyway, and when I went there, I had no concept of what I was getting into, what is engineering or anything like that. I just know that they said I had the aptitude and they pushed me in the area of science. And I didn't like the medicine thing. So I said the other next thing I know the people them who them pushing a science do is engineering. So I just go do that one. And it wasn't until way later on I start get an idea what engineering it is about. So I have to say this. It would be so great if we could find a way to understand what we're getting into earlier on. Right? Because I'm sure that when you guys were doing signal and system and Fourier transform and all that something, you just want to get out of it because what is that? You know, I learned math business and something. But in order to be an engineer, you need it. But I guess the only thing the lecturer could tell you at the time was that no one could really show you how you're going to need it. Yeah. And that shortcoming persists. And it's like you don't know what you're doing until the end. You understand? I mean, I talk to myself.
Yeah. No, man, we're hearing, man, we're hearing.
Okay.
Yeah,
Yeah,
listen,
that's
sir.
So I think that's all I have. The other two slides is kind of summary. All right. So who get the link to this PowerPoint? So that you have it, did I?
Sorry, you can just paste it in the chat.
Okay. All right. Copy it. All right. So I'm gonna do that. So that's all I have for today.
All right, sir.
Sir, would it be okay if we continue working on the lab and submit it probably with the assignment? Or
Yeah, man, you can, all right. Now I'll give you, until, I know that I'm gonna put a lot of work on me. But I'm gonna give you until the exam day if you submit the lab and the assignment. Mark you can submit it at any time you finish it. And it would be instructive to try and do the assignment as quick as possible. It'll save you a lot.
okay, sir.
All right, so enjoy your week.
When we finish the assignment, send it to your email.
Yeah, man.